right, according to an expert for the automotive industry, 58% of Americans know how to drive a manual transmission vehicle. And then we're told that 370 Americans are sampled. In part A, we're asked, of the 370 people sampled, 235 respond that they know how to drive a manual transmission vehicle. And we want to find the sample statistic p hat. So the formula for p hat is x over n, where x is the number in our sample that possess some given characteristic. So in this case, that's the 235 who said that they know how to drive a manual transmission vehicle, and n is the sample size. So in this sample, that's 370. So since we're told to give results to 4 decimal places, we could actually enter the exact value, 235 over 370. That would be perfectly acceptable. But here we can also put in the decimal approximation accurate to 4 decimal places. So that's 0.6351. In part B, it says, under the assumption that the industry experts claim that 58% of Americans know how to drive a manual transmission is valid, what is the probability that the survey that we took in part A would give us a p hat that is at least as high as the one that was found? So we're assuming the experts claim to be correct, which is just telling us that the population proportion is 0.58. And so this distribution is the sampling distribution of p hat. We know from the central limit theorem that the sampling distribution of p hat is normally distributed with a mean of p, and we're given that the population proportion in this case is 0.58, and the standard error of the sampling distribution is the square root of PQ over N. So we can define our sampling distribution in Desmos with those parameters. So I've entered my sampling distribution over here in Desmos, normal dist with the given population proportion P as the mean, and then the standard error here as given by the central limit theorem, given that we have a sample size of 370. We can clearly check and see that the large sample requirement is met. The p hat that we found in part A was 235 over 370. For the sake of sketching it here on the distribution, I'll just call that 0.64. And so here's where that p hat is. We want to find the probability under the assumptions about the underlying population proportion p that our p hat would be at least as high as the one that was found in part A. So at least as high means that high or a larger value. And so this area is what we're looking for. That is the probability that our p hat is greater than or equal to 235 over 370. Now you can use the decimal value for the p hat here if you want to, but use the value with extra decimal places. So I'm looking for a right-tailed probability. So from the cumulative probability choices here, I'm going to pick region right, and I want to compute the area. So again, I'm going to use the exact value, 235 over 370, or if you prefer, you could use a variable name up here from where we computed the sample statistic, and then you can just put that variable name here in the normal dist function. It's up to you. It's really exactly the same. And so I get the probability of 0.016. That's only to 3 decimal places. I want 4 decimal places. So I'm going to pop that open and drop it down into the next line. So when I round that to 4 decimal places, I get 0.0158, and that's the correct answer for part B. Part C asks, under the assumption that the industry experts' claim of 58% know how to drive manual transmission is valid, what is the probability that we would see a p hat in our survey between 57% and 61%. So this is similar to part B. Again, we're talking about a probability related to the sampling distribution. This time we're talking about a between probability. So this area is the area that we need, and that represents the probability in this sampling distribution that we would draw a sample that has a p-hat between 0.57 and 0.61. That's what we're looking for. And so I'm going to duplicate my sampling distribution to a new line. And I just do that because I want to preserve my work for each problem part. And now I'm going to change my selection down here to be an inner area, because I want the area and I want it to be an inner area between my lower bound of 0.57 and my upper bound of 0.61. Again, over here on the distribution, I can see the graphical representation of the area that we're looking for. And the probability is given here. That is to 3 decimal places, but I want 4 decimal places. So I'm going to expand that and then enter my result, 0.5305. And that is the correct answer for part C.